Hello and welcome. In this session, I'd like to talk to you about the underlying infrastructure that we need for anything around AI, mainly being the data centers and the energy consumption of these. And also, of course, about as the title says, the efficiency of this data center infrastructure. There's no doubt about it. Digital infrastructure lets us do really great things, and we can even do things that we couldn't have done before we had digital infrastructure. Just to give you two examples. So we came a long way from analog testing in wind tunnels. Here I brought an example from NASA. Physical testing in wind tunnels always meant a great deal of effort. So a lot of probes to be set, to be calibrated, a lot of manual labor, and of course also a lot of energy was used in driving these wind tunnels. And that is now being replaced to a large extent by simulations. And these can be done via means of computational fluid examples, and that also lets us simulate things that we couldn't measure before, like this crosswind situation as it's being depicted here. It was very difficult to do in traditional wind tunnels. And another example here, we're moving from physical test driving to simulated test driving, and also for training for autonomous driving. A lot of this is being done in simulators. So there's no doubt about it. Digital infrastructure lets us really achieve great things, but as always, it comes at a cost. So there are sources that say that the training a single AI model, this of course depends on the AI model, but can emit as much CO2 as 5 cars over the entire lifetime, and this is including the fuel, and also the increasing use of electricity for training AI models is quite remarkable. So we know that the amount of electricity that is being used for applications around AI has increased by a factor of 300,000 in the years 2012 to 2018. So there's no doubt about it. We can do really great things, but this, as said, comes at a cost. And to these costs, I'd like to add a bit more of a context. So you might be aware of this remarkable achievement that by trial and error method, the robot arm was trained to solve Rubik's Cube. But it was also reported that training this AI model used as much as 2.8 gigawatt hours of electricity. And if you convert that amount of electricity to CO2 emissions that were produced while producing this 2.8 gigawatt hours of electricity, here's a small translation. So this would equal the CO2 emissions would equal to your average person traveling from Europe to Japan, but not by train, but by plane. And this is only not true for a single trip; it's true for a round trip. And you might already guess it, it's not only one round trip, it's 1,700 round trips. When I found this out, I was like, whoa, this is something, and we need to be aware of that even though we can do great things with AI and the underlying digital infrastructure, but we need also to be aware of what this does and where the electricity comes from. So if we use electricity, and we know that we need to use electricity to achieve all these nice things, we need to be a bit more conscious about efficiency around it. And if I say efficiency in this context, I basically mean three things. So first of all, there's efficiency in the digital infrastructure as such. So it is more efficient to have a lower number of servers run at high utilization rate than it is to have more servers running at a lower utilization rate. And this is just has to do with the fact that servers already produce or use quite a bit of electricity, even though they are not working very hard. So also at idling mode, servers can consume up to 70% of their full load in electricity. And that, of course, makes them less efficient in part loads, so to speak. So what we need to do is to take care that the servers are running at their highest possible utilization rate. Then also a third aspect, or a second aspect in efficiency, is the energy efficiency. I'm going to talk about waste heat utilization in a bit, but another aspect is the power usage effectiveness. So basically that is the measure of how much overhead electricity do I need to run the server. And this is mostly the cooling that is needed. So servers are running normally at mid temperatures, but they need to be constantly cooled to keep this temperature. And also we need to have this overhead as low as possible. And then there's also the flexibility in energy consumption. What I mean by that is that it does make a difference where in the electricity grid do I use electricity. Do I use it in a very stressed part of the electricity grid, where I do need to do a lot of redispatch and steering? This makes it less efficient. Or can I, if that occurs, can I move the compute job to another location where the electricity demand is easier, steerable, and by that more efficient? And then there's also the efficiency in the software stack, but that's where my colleague from Helio, Christoph, is going to talk to you about in a few minutes. So bottom line in this is we need to keep an eye on where do we host the IT equipment, because this really makes a difference in efficiency. Efficiency and energy, or energy and efficiency, I just wanted to give you a bit of more of context what this really means. So in 2018, data centers have consumed 198 terawatt hours of electricity, and the laws of physics demanded that the electricity was converted to heat 100%. 198 terawatt hours of electricity produced. If you translate that into power plants, you land in the number of these OK-sized power plants. You're running 100 large-scale power plants, and these are the ones as this one. So this is roughly 200 megawatts electricity. We're running 100 of these all year round to produce this electricity. But at the same time, we are producing fresh heat for heating purposes. And the heat what we are producing, or what people produce, including industrial application, accounts for 40% of the CO2 emissions. So in essence, this means, on the one hand, we are feeding the electricity to the data centers. They are converting the electricity to heat, but they blow it off to the atmosphere because they can make a good use of it. And at the other hand, at the same time, we're producing fresh heat. So the question, of course, arises: why don't we use more of the waste heat that's produced in the data centers and utilize it where we need heat anyway? And by that, being able to reduce the amount of fresh heat that we need to produce. So in this sense, energy efficiency means to use what you produce anyway. But why don't we use more of the heat that is being produced? The difference, or the complication, often arises from the temperature level. So IT equipment normally likes to be run at around below 30 degrees C. And if you try to cool that away with air, or with air that gives you at the exhaust, so at the end of the cooling infrastructure, gives you warm air at around 30 degrees C. But that, for heating purposes, is just not hot enough. So you need warmer temperatures, Thinking about your domestic heating, you normally, if it's water-based, you normally have temperatures somewhere between 40 and 60 degrees C. And then that's the part where the water cooling technology comes into play, because water cooling technology is able to produce or to cool away the heat and allows capturing the heat at as high as 60 degrees C. And that is quite enough to utilize for domestic heating, because those are the temperatures that domestic heating normally runs on.
So we now saw that thanks to the efforts of the SDIA and the members of the data center sector, there is a new generation of infrastructure being built that is much more sustainable by using the electricity more efficiently and reusing the heat that the servers produce in these data centers. But the question is, what can we as software engineers and as data scientists do to make use of these data centers, of this new generation of sustainable infrastructure? Simply using these data centers, of course, is already an important step compared to traditional data centers that don't reuse the waste heat. But is it really enough to just switch providers? The answer to that is not really, because as we saw before when Birger talked about the electricity use of AI and data science, there is a lot of risk to waste energy, and therefore one of the most important things that we need to do is we need to choose the right problems to solve. There is problems that just can't and shouldn't be solved with data science. But for those problems that we choose to solve with big compute efforts, we can actually do, with very little effort, we can actually achieve a lot and help the operators of sustainable data centers, that they can optimize their electricity consumption and also their heat production. The base layer, I would say, that we have to provide is we need in order to make software more efficient, we need to properly set constraints for the software that we run. We need to properly size the infrastructure that we have, and we need flexibility. Flexibility is absolutely key, and I will be explaining in the next few minutes why flexibility is so important. So when talking about flexibility, I created a small step-by-step guide to explain why flexibility is the most important thing and how to achieve it. So the first step is we need to engineer our constraints, which means that normally for example, when we have a new problem or question that we want to answer with a machine learning model or generally with a piece of software, then we just build the software with the assumption that there is infinite amount of hardware, and then when a problem arises, then we just normally throw more hardware at it, right? But this is very difficult when this counteracts the idea that Birger talked before, that we need to be aware and to make an efficient use of the electricity that we are using up in a data center. Just idling machines that are just there because at some point in the past, or maybe at some point in the future, we need the hardware. This is really not an efficient use of electricity. And how engineering our constraints can help is basically when we have a business reason, for example, when we need a model trained or retrained next Monday, for example. And what usually happens is, what we do is we just prepare everything, then just start training the model wherever it feels convenient for us. But once we become aware of the constraints, when do we need this model, then we can start achieving flexibility. And when we know that we need this model the day after tomorrow or next Monday, or I don't know, 1st of September, then this is something completely different than when we say, okay, we just start to train right now because the button is there. The second thing is, once we have these constraints, defined and outlined for us, then we need to enable the software to be automated in a way that we can optimize and make sure that these constraints are fulfilled, which basically means that we need to properly size and split the workload so that it can be distributed into the cloud or whatever, and therefore also containerize it, because containers is one of the basic requirements for being able to automate and orchestrate workloads. So whatever runs in a Docker container, and the Docker container has properly set and defined constraints, then we can really start achieving this flexibility. And then at the end of the day, we need to really start think about this flexibility in our software, because flexibility not only helps us achieve much higher rate of sustainability in the use of our infrastructure, but also on the other hand also helps us reduce costs. When we say, of course, we need to train a model right now where it's lunchtime almost, and electricity is very expensive. Of course, this costs more than when we train a model over the weekend or during the night. Therefore, flexibility is really a mindset that can help us make our compute, like problems that we solve with heavy compute. When we think flexibility, then we can make them more sustainable, cheaper, easier to use, and this is all benefits that we get from flexibility. So the most important thing that we can start doing today is we need to teach business about sustainable infrastructure, and when they start demanding it, then we can tell them, you know what, the answer to actually make our infrastructure more sustainable is we need to implement flexibility into software. The problem is that there is this quote I found, that whatever the approach to deploying machine learning model, it's usually not a core skill set of data scientists, which means that when we have this flexibility, making use of sustainable infrastructure then is a whole other set of problems. And that's exactly the reason why together with my co-founder I founded Helio, because we want to solve this problem. We want to make it very easy for data scientists to use sustainable infrastructure. So to sum this up and to slowly come to an end, we saw today that there is a challenge. Data science and AI, and of course also other areas of software, software-based solutions, they have a real world climate impact. This is real and this is measurable. And but we also saw that thanks to Birger, the SDIA, and all the members, there is remedy for this. It's not our hands are not tied. And this remedy can be summarized as infrastructure needs to become more efficient, which means we need to make a more intelligent and more appropriate use of the electricity that we have and of the infrastructure that we have. And second of all, we need to reduce waste, which in the context of compute means we need the heat that is emitted needs to be reused. And the third thing that we saw today is that we can start today. Everyone here can start today. And the takeaway is that if we want to start today, we need to allow for optimization in our software. And optimization meaning when a system needs to be able to decide and automate the use of compute based on these constraints that I talked before. We need to properly orchestrate the constraints so that the system can optimize the electricity consumption and the heat production. So we have efficiency in digital infrastructure that Birger talked about. We need to make sure that we reuse or not produce any waste in the first place. And this is something that everyone in here can help. And what Helio set out to do is that we need to achieve efficiency in software stack by providing flexibility to the underlying infrastructure layer. And with that, Birger and I would like to thank you very much. And I hope you are a little inspired to help us improve the efficiency and sustainability of our digital infrastructure.